So with that, let's begin. We're going to start with a little introduction to Oasys and the purpose of Oasys Primer. Then we'll have a very brief recap on what we covered in the previous webinar a couple of months ago. So previously we looked at how we create a seatbelt definition, how we create a belt path and fit it around our occupants. We looked at how we would mesh a fitted belt and have Primer create an automatic contact for us. So that was previously, but this time we're going to focus on our seatbelt definitions and what we do with them once we've got them. So we're going to look at seatbelt editing, seatbelt refitting, and some of the advanced features and settings available to us, which are very powerful tools and often what's required to get a nice belt fit for more complicated problems such as child occupants or more unusual seatbelt geometries in comparison to a standard adult occupant. So the Oasys software for LS-DYNA, those are the products that we create to help our engineers interface with their LS-DYNA analyses. We have 4. We're going to be looking at Primer today, so that's the top left image there. And Primer is our preprocessor. It's typically used for assembling, editing and checking models, and we're going to be focusing on the seatbelt aspects of Oasys Primer today. For post-processing, we have some more tools. We have D3plot in the top right there. D3plot's great for viewing your analyses, animating the results, cut sections, plotting contours, that types of thing. And we also have THIS, which is in the bottom right there, and that's for time history plotting and post-processing and more numerical data in two-dimension form, in graphical form. And D3plot and THIS can be linked seamlessly, and that's what's shown in the D3plot image there. We've got a THIS graph overlaying a cut section animation. And then finally we have Reporter, which is in the bottom left, and that's our tool that we use for automating post-processing. So it brings together the data from Primer, from D3plot and from THIS into one report that can be created automatically after an LS-DYNA job completes. So today's talk is looking at Primer. So Oasys Primer is a specialized preprocessor used only for LS-DYNA models. Primer's modeling tools and comprehensive error checking can reduce preparation and debugging time. Primer is fully compatible with the latest version of LS-DYNA, so no information is lost when reading or writing out model data. Primer's model management tools allow the CAE team to work in parallel on different components of the same model. And because of Primer's robustness and depth of understanding of LS-DYNA data, users trust Primer to work on complex models without corrupting or losing any data. We're on version 14 of Primer. That was released some months ago, and that's the version I'll be using today. I will make a note of any significant differences between version 14 and the previous version, version 13. And if you have any other questions about versions and what features are in which version, just ask those and I'll try to cover that at the end. So we'll begin with a little reminder of a couple of the key things that we looked at previously. The first of those is setting the current layer. So this actually has nothing to do with making seatbelts, the seatbelt menus within Primer, but it's very important that we do this prior to any seatbelt creation or editing process. And that's because any of the entities that we create as part of the seatbelt creation process, we need to make sure that those are stored in the correct include or the correct layer within Primer. There's several ways that we can set the current layer. One might be to right-click an entity from the model window and select the Set Current Layer option. A second is to go to the Include panel and right-click a specific include, and then from there there's a Make Current Layer button. And then the picture shown here is the last of the options, and that's from the part tree. We can right-click an individual include from there, and then there's a make current layer button from that drop down. So that's shown in green there. And it's important that we select our seatbelt include prior to creating it, or creating the definition, or modifying things. So it's important that we get into the habit of setting the current layer before doing these tasks. The next thing I want to mention is the seatbelt definition itself. So there isn't a star seatbelt keyword in LS-DYNA, so all of this information is stored outside of the regular data from your models. The seatbelt definition itself is a primer construct, and all of the data is stored after star end. So the little screenshot there, that's taken from an example deck shown in a text editor. You see the star end at the top, that's where LS-DYNA stops reading. Everything after that is then specific to primer. So we've got Seatbelt start, then we've got our seatbelt definition, some more data there about the mesh and the path, and then Seatbelt end. So everything between Seatbelt start and Seatbelt end is specific to primer and is the information that contains the data for your seatbelt definitions. And the reason I mention this is not because it's expected for you to edit this data, and in fact it's advised that you don't edit any of this data. The reason I mention it is that to take care that this data doesn't get lost when you hand edit your decks, or when you go from one preprocessor to another. There's no guarantee that another preprocessor will restore this information when the keyword is written out. And if this is lost, the nodes and elements for your seatbelts will still be there, but it'll be much harder to work with them using Primer's tools because they won't have an associated seatbelt definition. So that's just something to be aware of and to be mindful of when editing these. So this is where we got to previously. We worked through setting up a seatbelt for our adult occupant, and we'd had quite a simple mesh where we used one-dimensional seatbelt elements for slip rings and the retractor, and then across the occupant we were using shell elements. So I'll bring that model back in Primer now. We'll just remind ourselves of how it looked in Primer. So here we are. This is our model. You can see we've got these one-dimensional elements up to the slip ring from the retractor. We've got a mixture of shells and 1D elements across the chest, and a mixture of 1Ds and shells across the lap. So this is where we got to previously. If we wanted to look at what we did previously, we would go to the safety menu, seatbelts, and now we can look at our definition, for example. So this is the first thing that we create. We can sketch that. So these are all the parts that our belt contains or can be contacted with. So in this example, we selected the seat squabs, the chest, the arms, and then the tops of the legs there. So we can see all of those by pressing sketch. We could look at the fit, and this is where from this panel we could start to change. I'll just minimize that. We'll return to those options as we did previously as well. We can change the path here. We can do a fit exercise again, or we can go to mesh if I did the fit again, for example. You can see we're just fitting it. So this would be if we'd changed any of these points. We could do that. This goes for around 2,000 iterations. I'm just going to stop that there at about 1,500. I think that's good enough for the example. And then if we wanted to, we could go into mesh and contact. So this is what we had previously. So we worked through steps 1, 2, 3, and 4 to get to our finished belt mesh. So now that we have our mesh and our seatbelt definition, and we're happy with it, we're going to look at how we can edit it and how we can refit it, change the form of it. And editing the definition is really the strength of Primer seatbelts. So not only is it easy to create them, once you have created them, it's very, very easy to modify them. So in the previous example, we created this mixture of shell elements and 1D seatbelt elements. But now we'll look at changing that to just be a path of entirely two-dimensional seatbelt elements. And we can do that from in the mesh menu. We would simply, for each segment of our belt, select a different element type. We would have to input the properties for the element type if we didn't do it previously, but otherwise it's just a few clicks to change the element type. Once we've inputted those, and I'll do a quick demo of that in a moment, we would press the generate button, and then that would give us a pop-up which I'll talk through live, and we'd have to delete some elements. So before I return to the other bullet points on this slide, let's try that. So if I just accept that fit, and you have to do that if you haven't already in a session of Primer, you'd need to do that fitting. If I go to mesh, this is now what we were looking at previously, and what we have here is so this is the first of the differences between version 14 and version 13. Version 14, when we're meshing, we've got this panel here where we have a grid of element types and the starts and ends of belt segments. So a little reminder, a belt segment is the stretches of belt between ends or slip rings. So in this example, we have 3 segments. So we have the start here, then a slip ring. So this vertical section is one segment. Then we have slip ring to slip ring from the B post to the buckle. So that chest portion is a second segment, and then we have the lap portion, which is from the buckle slip ring to the floor there. That's our third segment. So we've got 3 segments that we can mesh, and then we can control the elements at the start, center, and end of each segment. Previously, if we toggle this button, this menu looked like this. So if we were to change segment number 1 to 2D seatbelt elements, I would just simply select that option there, and you can see it's changed the icon there. If I toggle that again, maybe you can see it. So it's just changing so we can see those elements there. But I'm going to actually use the new menu, so I can demonstrate that. So we start here, we're selecting 2D elements, and you can see now Primer's put a cross through that end there. And the reason Primer's done that is because it doesn't think at the moment that that's a valid choice. So Primer's telling me that it would be an error to create 2-dimensional elements at this point. And the reason it does that is because at the second segment, we've got 1-dimensional elements. So that would be a problem. We'd have 2Ds and 1Ds going through the same slip ring. So I'm going to click that anyway, and then Primer tells me that I've got a problem by highlighting it in orange. And then if you also notice the little red cross in the corner there. So I can't generate that. Primer won't allow me to create this belt at the moment because I've got some problems. That's okay. I'm going to step through to my next segment. And we see here we've also got the same orange icon there for the 1Ds. But when I change that to 2Ds, we're now compatible. So we've got a tick there, and all of these boxes are shown as green. The same issue at the end of this segment, but then if I move on to the final one, we now have no problems. So I've changed all of those segments to be type 2-dimensional seatbelt elements even. And in doing that, we now have the 1Ds and the shell property buttons grayed out. 2D is red because we didn't input any data for that previously. So if I click that, I can type in the part ID for my 2D seatbelt elements, and then if I wanted to, I could also put in some element-specific information, such as the thickness or beta options. I don't need that, so I'll just update it. And now that button turns green, indicating that there's no problems there, and generate has become live, so I'm able to generate my new belt. As soon as I do that, I'm faced with this pop-up here, and this is important, this pop-up. So we need to take care when we select from this menu here. So we've got 3 options. We can reuse, delete, or leave. And what these are in reference to is the belt, the previous belt mesh. So we've gone from our mixture of 1Ds and shells to 2Ds. So obviously we're going to have the removal of some shell elements, some 1D seatbelt elements, but things like sets and the retractors and the slip ring elements, those can be recycled. So that's what we've got here, and that's the default option. So to reuse those, to recycle them. We could, if we want, delete them entirely, and then Primer would create new versions of those. Or we could leave them, and then that might result in duplicates that you'd need to manage. I'd say 9 times out of 10 you're going to want to reuse those, because it means that you don't have to redefine any of the settings as you would if you were to delete and create them from fresh. So that's what I'll do here. I'm going to press reuse. So now our Primer's brought up the deletion menu. So in here we've got our previous shells and seatbelts, we've got our previous nodal rigid bodies, some sets from those nodal rigid bodies, and I can just delete all of those. That's okay. Press continue, and then Primer gives me this little information summary pop-up, just the same as we got the first time we made this belt. I can press OK to that. And you see Primer has meshed our new seatbelts. So this time we've got 2D seatbelt elements. It's the same fit as before. We did that quick refit, but otherwise it's looking good. We've got our little summary panel on the right hand side as well. So this is where we are listing our checks. Everything's okay there, and because we reused those retractors and slip rings, if I was to interrogate those, the information there has been remembered. So we've got our sensor ID, our load curves. If we deleted and created from fresh, these would be blank, so we'd have to fill in those again. And with that, we've meshed our belt. We could leave our seatbelt menu now, and we've got a brand new belt with a different mesh. So that's why I had just on this slide a couple of bullet points about that reuse panel. We say typically you're always going to want to reuse, and then it's okay to delete when prompted here. That's just a little check there. So with that, that's editing. Very straightforward. Hopefully you'll agree. One final note actually is it's not as necessary as you might think, but just in case, it's often worth, after doing a remesh operation, just doing a cleanup. So we do that. If I just go back to Primer for that, we can do this cleanup. Go and remove, cleanup, model, apply, and then things like segments or segment sets that might have been created in the previous belt definition, and they may get left over, and this is just they won't do any harm to your model, but it's nice just to tidy that up. I've got some other things in this model that is part of the cleanup, but in terms of the seatbelt, there was only these segments, I think. So it wouldn't have done any harm to leave those, but if you wanted to, you can remove them. Okay, so moving on, refitting a seatbelt. So this time we don't want to change our mesh type. What we want to do is to refit the belt around our occupant, because we've moved the position of the occupant slightly. And we could do it using the fitting panel. So that was menu 2 here. From when we were creating it, we could edit the fit and then redo the mesh just as we did a second ago. But actually, it's a little bit faster for this type of operation if we use the AutoRefit menu. So in that menu, this is it's designed to quickly refit an existing belt around a slightly different position occupant. It's a little bit faster than maybe changing the points manually, updating the mesh as we just did in the previous example. So this panel looks like what we've got here. Let me bring that big again. We've got these tick boxes on the left hand side, and that's for the types of update that we want to do. So do we want to update the belt path? yes or no, and that would be if the nodes on the are still associated with the path points. The path points will be updated as with the node. Do we want to refit the belt? Typically, yes, of course. Do we want to remesh the belt? Do we want to recreate the contact? So those are just the things that we did before, really, the 1, 2, 3, and step 4. We've also got some options on the right-hand side there for labeling, and if those were set up in the original belt, those will be remembered. We've got a couple of other options there, but typically you just want to leave all of these turned on, and that's going to give you the most complete and the most error-free refit. So I've got an example of this where we take our occupant from previous, and we've moved them in a slightly different position, and we're regenerating the belt. So what we're aiming to do is to go from this position here to a new fitted belt. So if I just bring up my example for that one. So here we are now. So this is our old belt definition. So it's 2D seat belts like we created a moment ago. But this time it's a bit contrived, but I've pulled the occupant out of position. So he's a little bit out of position, and you can see there the old belt is just cutting through the chest and the lap. And the best way to fix this then is to go to Safety, Seatbelts, same options as before, but this time we're going to use AutoRefit. So here's that panel. I'm going to leave all of these ticked. I'm happy to redo all of those. I'm happy with my labeling. So when I press Apply, you can see there Primer's redoing the fitting process. So it does around 2,000 iterations. I let those complete this time round, and then once that's completed, I get the old mesh is removed, it's deleted, and then the new mesh is created. So I don't have to confirm the reuse or get the delete panel up this time. It's all done behind the scenes. All I get now is a confirmation and a summary of what's occurred. So if I press OK, you can see my belts updated there. It's always worth, whenever you do any of these refitting or auto refitting operations, that you inspect your belt. So we're looking for any crossed edges, any penetrations, because the buckle's okay, that wasn't in the definition to start with, but we're really looking for crossed edges on the chest or between the belt itself, belt to belt issues. But in this particular example, Primer's done a nice job of it, so there's no need for me to do any additional tweaking. If I needed to tweak it, then I would have done so using the same options as we used to create it originally. So that's it for editing and refitting belts. Not too much to it really. It's hopefully quite straightforward. So now what I want to move on to is looking at the more advanced features in the settings, and those are what's typically used for getting a nice fit on child occupants or more complicated belt paths. So to begin with, then we'll look at the fitting options menu, and that's where we can find a lot of these settings. So this is the panel that pops up when we go into the fit option. So that's the number 2 option of the seatbelt panel. And what we've got there is at the top of the definition, we've got several preset options. So we've got adult, which is the default, child, and general. This doesn't really affect the belt creation as such. What these options do is they change the rest of this panel. So all they do is they change the other options on the panel to what we think is better suited for a child or for an occupant, an adult occupant. And you could further change them yourself. It's just a sort of a starting point, what we think is the best options. So in this, we've been previously using all of the adult presets. I'm going to use the child, and I want to talk through the different options we have for using the child. So path order is the first of these options, and actually it's not it's not changed for the child or adult preset, this particular one. The others are. This one's defaults as spline for both of them. And what Plat Order is, we discussed it last time as well, and it's the shape the belt takes between the points. So spline gives a nice continuous smooth belt. Linear gives a simple straight line segment, so those are the two pictures we've got there, and mixed is an average of the two. Default certainly is, well, the default is spline, and it looks the nicest. Visually, it's nice and smooth. It gives a realistic appearance, and it's typically the best one for adults and for some children. But for very narrow routing, then you might find a mixed or a linear path is better, so you can control a little bit more tightly the path of the belt between the different points. We've got next on this menu then is point offsets, and that's how far the belt is away from the unfitted belt is away from the point that we create on the path itself. So if you remember, we create these paths by selecting nodes on our occupant or on our structure, but the belt obviously sits some distance away from those points. And that distance is a fixed distance, and it's by default 35 millimeters for adults, whereas for children that default is 35/10, so 3.5 millimeters. And that just makes it a lot easier to weave around the belt structure without having issues where the belt is being projected too far away when you've got these tight geometries. So that's what we've got on the right hand side there. It would be very difficult to fit the belt around that child seat if it was being projected each side 35 millimeters. The two sides of the belt there would be going through one another, for example. So this is the first thing that changes when we use the child preset, and it's something to be aware of because it's really essential for these more complicated belt paths. In version 14, we have the ability to change that 35 millimeters individually for each point. So in the previous panel there, we could type in a new value, and that will be applied to all of them as a new default. But from this version 14 onwards, we can now change the projection for each point individually, and we do that using the menu here. So this is where we're editing a path definition, and we can change this by clicking the project button there. So that's the bottom right of the highlighted ones. When we do that, we get this picture on the left where the projection vectors are drawn as little arrows, and we can just drag on the screen our belt away from those. And by doing that, we keep the association between our node and our belt point, which helps with the refitting, of course, and when changing dummies, which we'll see later. Radial vectors is another option available to us, and it's one that changes with the child preset. The default is local normal, so the belt typically takes the form normal to the occupant. That's for an adult, whereas that doesn't really work very well with a child. For example, if I was to select this point here, and the point 12, I think you can see my cursor hopefully. So that's this point as the belt goes underneath that arm of the booster seat there. If I had selected the booster seat as my node there, then you can see that the belt is not parallel, but it's similar gradient to the underneath of that seat, but that's not really what we want from this belt here. A better option for children is the path twist algorithm. So that's something that we have developed in-house, and it just gives a nice more gradual routing of the belt. It's worth saying that as soon as you start changing the twist of any of these points, that just supersedes this anyway. So I wouldn't dwell too much on the radial vectors option, but if you're using the child preset, then you'll get a better starting point in terms of the belt twisting anyway. Initial depenetration. So not necessarily entirely applicable for children. This is just as applicable for adult occupants as well. It's a tool that we put in to help with both. Ideally, the user should have created a belt path that avoids any initial penetrations or any initial crossed edges. But sometimes that's difficult to achieve, so this tool just tries to remove those prior to doing the belt fit. So what we see here is we've got some crossed edges or penetrations with the jacket of the occupant there in the belt. If we've got this initial depenetration turned on, it's turned off by default. We get some local fixing that occurs in the belt. So that's what we see here. So we get some local movement of the sort of belt nodes there prior to fitting. Obviously that looks a little bit strange there, but then during the fitting that gets pulled tight, so it doesn't affect the final form. This would be essential if you did have crossed edges, because crossed edges basically ruin the belt fit. It doesn't, just like an LS-DYNA analysis, it snags the belt contact and the belt can't be pulled correctly anymore. It's worth noting that we're still developing this tool, and there are some geometries where it doesn't work so well. That's where you've got this edge-to-edge type contact there that we see at the lap. It's worth trying, but it's not as robust with that type of contact. Belt-to-belt penetration is another option that we have available to us. Depenetration, and that's similar to the initial depenetration. This time it's turned on by default, and it's looking specifically at the belt-to-belt contact. It can be turned off if you wanted to for speed, or if it's misbehaving and creating some spurious movements, but in many cases this works very nicely. Sometimes it's worth changing the belt thickness artificially over a given length of time, making it a little bit thicker, as that can help during the initial form finding process. We can do that from this panel as well. So we've got two options: initial factor and ramp iterations. And the factor is applied to the belt thickness at the first iteration, and then over the ramp we slowly decrease the belt thickness down to its true thickness. So that just gives if your belts are quite thin, it can help with the initial contact to start with, to have it a little bit thicker, and then slowly as things stabilize, as they converge, we can progress to the true thickness. Relating to thickness, we can also control the shell thickness for the regular belt to structure contact. We can do that from the options panel. We have three choices. We can use the actual thickness, which is the default. If we find that that's not enough, we can apply a scale factor, so that's the center option there. That might be useful if you've got very thin null shells, for example, that you've used as your definition. Or finally, we could even use the neutral axis and the mid, so that's the mid plane of the shell elements. Default is the true values. I think for most cases that's fine, unless you, as I say, you've got these very thin null shells that might be worth using the factor for. This doesn't affect our belt fitting or the result, but it's often helpful for the user when they're creating this. We've got some options available to see what's displayed visually. So we can change the belt itself from a thick shaded to a skeleton view, and we did cover this last time, so I'm not going to go through all of these settings, but the one I really want to remind us about is what we're showing in this middle highlighted box here. So where we can change the segments that we're showing. So by default, all of the belt segments are shown, so between the ends and the slip rings. But when you're working with the child occupants and the belts are often going back on themselves, it gets a little bit confusing, and sometimes it's better to just work one segment at a time while you perfect the path, the shape, the twist, remove crossed edges, those things. So being able to just visualize one segment at a time, like we have here on the right hand side with the lap portion of the belt, that's really, really powerful, very useful tool. So it's worth bearing in mind that we can do that from the fitting options menu. So we're now moving out of the fitting options menu and looking at another tool available to us when we're fitting child seatbelts. And this is known points. So known points, known positions. There are points on our seatbelt that are not going to move when we do the seatbelt fit process. So when we press fit and it gets pulled tight, the other points, they can move around and slide on our occupant. These known points, they're fixed in space. And it's really useful for child belts because we often got to navigate very tight geometries. So what we're showing there in that middle option, that middle picture, is a known point for the belt to pass through that collar there. We can change a regular point to be a known point in the same way as we would identify a slip ring point or a fixed retractor point, and that's from the path edit menu, and we have a list of path points, and we would right click one of those points, and then it's down at the bottom there, K, known position, and it's shown as pink there. And those are really powerful points for in our arsenal for when we're trying to fix these child belts. So just to really drive that home then, for example, this is a really nasty seatbelt to fit. We've got our child occupant set on a booster seat, and then the belt comes down and has to get between the hip of the child and the wing of the booster seat down to a buckle, and then back again along the same path. And I had to use to fit this. I required the preset for the child, so the radial vectors settings, the offset settings, and then also for this particular example, I needed to switch to the mixed mode of path. So rather than use the spline, the curved version, I had a mixed version. So it wasn't purely linear. I did keep some curvature, which I needed over the chest, but I found that having the mixed mode worked well to try and navigate this very thin path between the occupant and the booster seat there. And then also to get the belt through there and back again, I had to use four known points, one either side of that thin little slither of available space. And overall, 24 different points were required to fit this belt. So often where I would say when you're fitting adult belts is to start with as least as possible and build up the number of points. And that's what was done in this case, and we had to build up to 24 points to get this to work. Mesh slip rings, we mentioned this last time, so I'm not going to go into it in too much detail, but it's the final option in the fittings menu there, and it allows us to change a regular slip ring to a meshed in slip ring. So the options for that are from the big panel, and we can identify a meshed in slip ring from the path panel just the same way as we did a known point a moment ago. And what they look like is Primer uses an imaginary cylinder of a given radius that we specify, and it pulls the belt around that radius. We have to give it a transition distance of the coarse to fine mesh, and an angle which controls the fine element size. The idea is that the primer would create this belt form, and then you would have your own buckle mesh in there. So primer doesn't use a mesh or anything; it just uses this imaginary cylinder. And that was added from version 13, and it's in there in 14 as well. Something that we looked at last time, in a little bit more detail. So then one of the final things to look at today then is the new dummy tool. So that's the last of the buttons in the seatbelt menu that I'm going to look at, and this is the tool. It's adjacent to AutoRefit, and it's the tool that we use when we want to change dummies. So we don't just want to do a refit, we actually want to entirely change the dummy. So the first step of this process is to obviously change an old dummy with a new dummy model. You could do that in Primer, maybe it's a text edit of an include file, but either way this is done outside of the seatbelt panel. So once you've swapped your dummies in and out, you then go to the seatbelt panel. So that's what I've got here in this picture. I've swapped my previous occupant with a new one, and you can see that in the old position and the old occupant, maybe the old one was saying 95th, for example. This is a 50th percentile. This belt's a little bit too big, so I need to pull this a little bit tighter, create a new belt. When we enter this new dummy panel, we get this particular menu here, split into two halves. The top part is a check for the parts that are in the dummy definition and that the belt can contact. So Primer will either say it's okay and give you a little green man with a tick, or a red man with a cross if it's not okay. And we'll see in the example that sometimes Primer might say it's okay, but you still need to check because it might not actually be okay as you expect. So that's the top part, and then the bottom part is a check on the different points. So the points that make our belt, and whether they're okay or whether they need some attention. So this is best shown in an example. So I'm going to go to my third and final example. Here's our new occupant in our old belt. I go to safety, seatbelts. I go to new dummy, and then I get this. So I just move that up. We get this option here. So first of all, Primer thinks that things are okay, but we're going to check that. And then also you can see here that Primer has identified the points on the structure as being okay. So as it should be, I haven't changed the structure, but I've got some points on the dummy that are not so okay. And actually those are sketched there, so we've got our points. And if you can just make out, I'm sure it's easier on your own screens, Primer would say no node defined there, or it might say there's a latent node. In my particular example, no node is defined. That's because there was no nodes associated with those points prior to swapping out the occupants. Ideally, what we want to do is make sure that everything on these two panels is green and we get the ticks. So first of all, if I just sketch things there, you can see that this is the contents of my definition now. So I've got my belt and my seat scobs, and in this case, Primer's identifying the seat scobs as being valid parts in the definition. But that's not actually the case. We've got to add in some extra parts there. So I'm going to check the chest, the arms, the lap, and the top of the legs. So I'm just adding new parts to this definition. If my occupant had the same number range, my old and new occupants had the same ranges, the same part IDs, then I wouldn't need to do that. But now when I do sketch, you can see I've got the occupant is in there now, and also you see down here, as soon as I did that, I now have ticks for my path points. If I didn't have any ticks, I have some options available to fix those. So I've got check path coordinates, and that looks at each path point which has a node associated with it, and if the node is latent or it's more than the tolerance of 5 mil away there, the node would be removed from that point. So that would break the associativity between the current point and the previous dummy node. And then once those path coordinates have been broken, those links have been broken, we can then click the Find New Nodes button. And what that does is it looks for the nearest node to a given path point within the 50 millimeter tolerance. So now I've got some nodes identified here. You can see those in green, connecting the points to my old seatbelt definition, the new nodes to my old seatbelt definition. So with everything in green and ticked, I can press Update Dummy and Belt Path. And now that's fixed my definition, so it's updated it and there's no errors. And now I'm free to do the auto refit just as before. And then this time Primer's pulling the belt over the new occupant. So I just stop that early. If I do that, if I stop it early, I have the option of aborting or accepting. I'll just accept. I get my summary option box, and then of course we need to inspect it, and then actually it looks pretty good. There's a small little penetration there, and then I might need to fix that. Maybe it's easy to do it by hand, or I would go into Fit and then I would start tweaking this so that it is compatible with my new occupant. But certainly for a first pass, and as a new occupant and a new belt for a new occupant, that's a pretty good job it's done there. So this is what we've seen there. We're trying to make sure that all of these are green, so we need to tick there. All the nodes are okay, and then green ticks down at the bottom there. When that's the case, we can press update to my path, do an auto refit, and then we have our new belt. As always, we need to check it for very small errors. Might need some final tweaks, but as a first pass, this gets us very close to what we want to work with. And then finally, I've got just a little note on some of the additional settings that can be found. So these are less likely to be used regularly, but you might want to visit them if you're having some real problems fitting a belt. They're located from the Fit menu, but rather than the pop-up that we get, there's a button from this menu, Fitting Params, in blue there. That takes us to this options panel. There's some options for the iterations and things. I don't suggest you change any of those. The two that I've highlighted here as being potentially interesting to you is the curve and the friction values. So the curve in there, that's an angle that dictates how curved the belt can be. So it's by default 30 degrees. The two pictures I've got on the right there, if you can make it out, that belt has been pulled very tightly. The upper belt has been pulled very tightly, and there's a 0 degree limit on that, so it can be pulled as tight as it needs to go. In reality, obviously, there's a bit of a membrane stiffness to the seat belt, so it doesn't go as tight as that. 30 degrees is what we think is reasonable. This particular image is 10, and you can see it's just a little bit smoother there. It's not as concave, it's not as tight into the crease of the lap. And then lastly, we've also got friction, and that just puts a value on the transverse friction. So it's the friction of the belt as it slides on the plane of the occupant of the structure. And if you find that the belt slips off the shoulder or into the neck joint, for example, then and it's hard to avoid that slipping, you might want to increase the friction there, and it'll limit the amount of slip that the belt can experience during the fit process. So a full explanation of these is in our manual. I don't want to go through all of them in detail now, because I don't think really many of them need to be changed. It's really just that curve and friction I want to draw your attention to. Okay, so that concludes the second part of this series in Primer seatbelt webinars. Hopefully you found this useful. Thank you for listening. As always, if you've got any questions, just let me know. And today's video and the last one will be on our website shortly. So thanks again, and goodbye.